Alright, so here in this video, I'll show you how to attack a few multiple choice questions regarding projectile motion. So here's the first of few in this video. It says, which of the following is a true statement regarding the motions of projectiles in general? Neglect air resistance, select all that apply. So read A, B, C, D, and E. On that, I will show you, I'll go ahead and show you how to assess these choices, okay? So here's the general diagram. An object is being shot and it follows some, trajectory here and it strikes the ground or whatever the case is. So we're looking for true statements. So in this particular problem, I think this animation will help you assess which of these choices is true. Okay, so if you want, watch this animation. I'll let it play a couple times here before I show you how to attack A, B, C, D, and E. Okay, I'm going to just let it reset real quick. All right, so here we go. As it starts, you notice that your velocity vector in red is big, but as it approaches the peak, it shrinks. It shrinks because Vy keeps getting smaller, and it approaches Vx at the peak because those two arrows overlap. The red and blue arrow overlap. And as it falls back down, Vy grows. As Vy grows, V also grows because of Pythagorean theorem. Okay, so once again, excuse me, on the way to the peak, V approaches Vx. On the way down, V keeps growing and growing and getting faster and faster and faster. Okay, all right. So generically, here's a diagram for you. Once again, if you need to draw stuff out, here's your Vi, here's your Vix, okay, and then here's your Viy. According to this diagram, Vix points to the right, Viy points upward because it's being shot from left to right. Okay. But at the top, as you saw in the animation, at the top, your velocity vector simply reduces down to just Vx because Vy at the peak is 0. Okay, so for that reason, you can apply Pythagorean theorem. As you can see, these vectors form a right triangle. The horizontal and vertical component just makes this into a right triangle, which allows you to use Pythagorean theorem. But choice A says here, the velocity of projectiles is smallest at the apex. Well, how do you know if it's true or not? Well, at the apex, Vy is 0, so you can cancel that out, which reduces down to just V instantaneous square is equal to Vx square. Well, the square on both sides will cancel out. That'll just leave you with V of t, right? The instantaneous velocity at the apex. Why? Because Vy is 0 at the apex. It's just Vx. So if you just use common sense here, you're not adding anything in this statement. Therefore, Vx is the smallest speed in this particular types of problem. So for that reason, A is true. So the velocity is indeed the smallest, or is smallest at the apex. Okay. Now let's do B. It says all projectiles have 0 velocity at the apex. That's kind of whack. Okay. Vy is 0, but the velocity itself is Vx, as proven here in the Pythagorean theorem. Right. This statement says the V of t, the final velocity, is Vx. It didn't say 0. So keep that in mind. Vy is 0, but not the velocity itself. The velocity itself is now just Vx. If you need to rewind the video, watch that animation again. All right, let's move on to C. C is whack as well. It says the acceleration of a projectile is greatest at the apex. No, the acceleration is simply the acceleration due to gravity at every single point during flight. So the fact that it says greatest is super duper whack. Okay. All right, let's do choice D. Choice D says the projectile's velocity is 0 at the apex. Well, once again, if you've been listening, the velocity is not 0. It's the velocity in the y direction is 0. Okay, so anytime it uses the term velocity, you have to think of both x and y. So for that reason, I'm going to cross that out. Okay, so and then here is what is this? Oh, this is to help you understand C. I forgot that I have these arrows for you. To understand C, why I cross C out at every single point that, as I stated earlier, is G. Okay, so the acceleration is simply just G, and G is the same at every single point during flight. So I just drew you a bunch of arrows here. So all these arrows are the same size, and they all represent G. Okay, so cross D out. Why? Because it's just whack, right? The velocity is not 0 at the apex. The velocity is Vx at the apex. E. It says the velocity and acceleration vectors are perpendicular at the apex, which is true. So if you look at the apex here where the Vx is here, at that point, G is just pointing down the page. So Vx is in the x direction, G is in the y direction. X and y makes 90 degrees, which is the word perpendicular. So here I put in 90 degrees for you. So the statement E is true. So at the apex, it is the only location where V and A are perpendicular, okay? Other than that, it is not. All right, let's do this one. Here it says a cannonball is fired with an initial velocity of 20 meters per second and a launch angle of 45 degrees at a wall 30 meters away. It says if the cannonball just barely clears the wall, what is the maximum height of the wall? All right, so I hope you're listening well here and listening carefully here. Yeah, even though the phrasing here uses maximum height, okay, new folks might be tempted to use the H max function. So if you don't know how to derive this just use common form in the vertical direction. Okay, so this is kind of a trap. The terminology uses the two words here, maximum height. So you might be tempted to use the H max equation because it says maximum height. However, you always should check to make sure whether the wall is at midpoint. Okay. The only way you can use H max is if this wall is at exactly halfway in the horizontal direction. In this problem here, it says that the wall is 30 meters away. Oh, I don't know if 30 meters is midpoint, so I need to run a test. Well, how do I run a test? I need to find this whole entire length here, aka your horizontal displacement. Well, in this problem, assuming the height of the ball here is, starting on the ground and it just gets shot out through the barrel and come all the way down, or we can neglect the height of the cannon here, that the range function can be applied. Well, here, vi square sine 2 theta over g is your range function. It allows you to find this horizontal displacement. So if you plug in vi is 20, you want to square that, and then sine of 90, because it's 2 theta, and theta being 45, so 2 times 45 is 90, and then you want to divide that by g. G is 9.8. This range function here already accounts for all the negative signs, okay? So just in case you're wondering, you don't need to plug in negative 9.8 here because visually there's a negative sign on top, but I just like to cancel it out already. So it doesn't really matter, right? You can flip the image left or right, but the horizontal distance is still the same, which is 40.8. Well, the wall is placed at 30. Half of 40.8 is 20.4. So, but this wall is not at 20.4. It's actually placed at 30, which implies that you cannot use this range, or excuse me, you cannot use this H max equation. So it's always important to kind of run a test and make sure if you can use functions or not based on what they represent. H max is at the peak of the flight, which is midpoint. The wall here is placed at 30 meters, which is not midpoint, so therefore you cannot use the H max equation, okay? You have to resort to your regular kinematics. Now, so let's do it. So here is VI, VIX, and VIY, okay? And VIX is VI cosine theta, VIY is VI sine theta, and that just comes from your SOHCAHTOA trigonometry days. Now, well, how do I find what the height of the wall is, right? Ultimately, the question is looking, what is the maximum height of the wall that it can clear? Well, use your kinematics. Your vertical displacement is VIYT plus 1/2 GT squared. Plug in stuff that you know. Well, VIY, as shown in the diagram, can be broken down to VI, which is the hypotenuse, times sine of theta. So substitute out VIY for VI sine theta, carried over the T. And then here, instead of saying 1/2 G, I just went ahead and simplified down to negative 4.9. This is negative 4.9 because 1/2 times negative 9.8 is negative 4.9, okay? All right, so as you can see, you have values now. Well, VI is 20, which is given. What's theta? Theta is 45 degrees. You notice here I highlighted T because T is the only thing I need to find in order for me to find my vertical displacement or the height of this wall, okay? So how do I find T? Well, the problem gives you enough information to find T, right? It says that the wall is placed 30 meters away, which is the horizontal displacement. So you can just use your kinematics in the horizontal direction. So here delta x is just Vxt. Keep in mind, acceleration in the x direction does not exist, right? The only acceleration for these types of problem is just acceleration due to gravity, which is in the y direction. So, but this statement is for the x direction. So to find your horizontal displacement, you just need the velocity in the x direction and the time of flight. Well, I need time, right? I need time. On the left side here, I highlighted T once again. So focus on what it is that you need to find. I need time. So I can break Vx down to Vi cosine theta, right? This says Vx. You can write Vix if you want. You can write Vx if you want. Vx doesn't change. So adding additional subscript doesn't really do anything for you, okay? So the only thing here that I'm missing here is T, right? Delta x is Vi cosine theta T. Well, I know delta x is 30. I know Vi, and I know theta. So if I can just solve for T, so I can just plug stuff in. To solve for t, divide both sides by vi cosine theta, and then plug in delta x is 30, vi is 20, cosine is 45, and if you clean this up on your calculator, you'll get a time of about 2.12, and then you plug it back into the left side, right? The only thing holding us back here is time, so t here is 2.12 seconds, and then I want to do that for both of these t's down here in yellow, and if you clean this up on your calculator, you should get a height of about 7.96. All right, so that matches choice D. Right, so let's move on. In this next one, it says here the diagram below shows the path of projectile where points B and J are at the same height. So this is important. So if you look at the diagram here, this is point B, and you go all the way to the right, that's point J, and they are located at the same height. And it says if we compare the directions for the horizontal velocity and the vertical velocity and the resultant velocity, just V, at point B and J, which of the following changes? Well, let's just use common sense, okay? I want to cross stuff out that cannot change. Well, in this, Vx cannot change. Vx stays constant throughout the whole flight, okay? So this question is looking for what can change, right? Which velocity or t's plural here can change? Well, I'm looking for stuff that change, so I can cross stuff out that doesn't change. Well, Vx is kind of whack, right? Again, here's the animation for you in case you weren't watching in the first example, right? This animation shows the blue arrow, and this magnitude of the blue arrow stays the same throughout the whole entire flight because it does not accelerate in the y direction. So for that reason, I want to start crossing stuff out, okay? So here's V, here's Vx, here's Vy, blah, blah, blah. And then on part J, though, the arrow is just now pointing down because it's on its way down, but Vx once again still points to the right, and then Vy just points down, okay? So I can cross stuff out. Choice A says Vx only. Nope, that's hella whack. Vx cannot change. So I'm going to cross all the answer choice that has a Vx in it, right? C has a Vx in it, E has a Vx in it, and then what else? G. G has a Vx in it. Vx cannot change. I'm looking for stuff that can change. Well, B here says Vy only. Well, that's kind of whack. On the left side at point B, Vy is pointing up. On the right side, Vy is pointing down. So did the direction change? Yes, right? However, it is not the only thing that changed. Well, if you look at the vector here for V here is pointing in the northeast direction. However, at point J, V is now pointing in the southeast direction. Well, northeast and southeast are two different directions. So did the vector itself change? Yes. Why? Because Vy flipped, okay? So I want to cross out B because it says only Vy. Nope, Vy change, and because Vy change, V also change. So I want to cross out D. It says only V change. That's whack. So in this case, F is your answer. So as it is in flight, Vy flip, and because Vy flip, V also has to flip with it. Okay, so answer is F. On this one right here, it says here are 3 balls, 1, 2, 3 rolls out horizontally off of a table at different speeds, V1, V2, V3. And this is if the balls fall from the table simultaneously at the same time and follow the parabolic trajectories shown below, which of the following statement is true, and select all that apply. All right, let's crack it out one at a time here. Choice A, all 3 balls strike the floor at the same time. Yes. All the balls are being launched horizontally. There is no y component to consider for the velocity, so therefore we can just use kinematics. Well, how do I find time of flight? Use your vertical displacement function. In this case, for all 3 of them, they're launched horizontally, so the initial velocity in the y direction is 0 for all of them. So as you can see here, delta y is the same for all 3 because they roll off the same table, so therefore delta y is the same. So I made a note for you here. Y is the same. So just use common sense. Y is the same, G is the same, so therefore T must be the same for all of them, right? You can't have a different T, especially if your height is the same and G is just acceleration due to gravity that you cannot change. So therefore, I want to highlight A, just using common sense. Now, B, it says V3 is greater than V2, which is greater than V1. Well, how do you know if this is true? I would say just by looking at it, right? V1, V2, V3. V3 lands farther away from the base. Well, to land farther away from the base in the same amount of time, you have to be moving faster. You know, so to me, that's an intuition thing. To cover more distance in the same time, you must be traveling faster. or you can prove it, right? So here's your horizontal displacement function. So if you look at all three of these, right, I circle T here because T is the same for all of them. So if you understood choice A, I think you understand why I circle T. T is the same for all of them. Well, if you look at this, using your visual, well, which one land farther horizontally, delta x is bigger for object 3. Well, if x goes up, then v has to go up, right? So using that deduction, we can say that v3 is the greatest because it generates the largest delta x, okay? So I want to highlight B as well. C, it says v1fy is equal to v2fy, which is equal to v3fy. So here, choice C only focuses on the vertical direction because they all have the subscript y, right? Well, how do I know this is true? Well, again, if they all fall from the same height and vi y is 0 for all of them, they fall the same vertical displacement in the same amount of time. So due to acceleration due to gravity, you'll reach the same velocity in that direction, or you can use common form. So here I want to use this strategy instead. Here I can cross out VIY because they're all launched horizontally, and I'm comparing VFY, but once again I want to circle delta y for all three of them. They all fall from the same height. So because G is a constant, delta y for this problem for all three objects are constant. Well, you take 2, which is a constant, times G, which is another constant, times delta y, which is the same constant for all of them. It would say that VFY would equal to the same answer for all of them. So I want to say that C is also right. Okay. A. Choice D. It says A3 is greater than A1, which is greater than A3 is greater than A2, which is greater than A1. That's hella whack. The acceleration for any objects in flight is just acceleration due to gravity, so that's just stupid, okay? Don't fall for traps like that. E. It says here V3F is greater than V2F, which is greater than V1F. So here it's looking at the actual vector itself, right? V3F is made up of V3Fx and V3Fy. Likewise, this is the actual vector, not the component, so make sure you read statements correctly. Well, how do I know if V3F and is greater than V2F, which is greater than V1F? I would say use common sense. If choice C is right, you can apply Pythagorean theorem, right? Pythagorean theorem tells you need Vx squared plus Vy squared. But all three of them have, ready, the same Vy, right? They have the same Vy because they all three fell the same height. So this is the same for all three of them. Well, how do I compare V then? Well, in this case, you would say Vf depends on Vx. Whichever has the greater Vx will generate the bigger answer because you're adding, right? So, using common sense, once again, I stated earlier, by looking at it, which one has a greater Vx? Well, object 3, it traveled a farther horizontal distance in the same time, which means it has a greater Vx. Therefore, I would say that E is true because V3 has a greater Vx. Well, Vx is greater, therefore, when you do Pythagorean theorem, the answer on the left side would also be bigger. Okay? I hope that helps. Stay nerdy. Don't be whack.